In this presentation, I'll introduce the tilde out rule, and then we'll do a first set of 10 practice problems. So the tilde out rule is very similar to the tilde in rule. The only difference is your starting point. So what you'll have is you'll have a conclusion, and you won't be able to prove it from your premises. So you have premise 1, premise 2, and you won't be able to prove it directly from the premises. So what you have to do is you have to make a PA with a tilde included on the conclusion. Then you'll look to build a contradiction just like tilde in. And then from these two things, you'll end up getting the conclusion doing tilde out. So what the tilde out is doing is it's removing this tilde that's next to the conclusion. So it's going to look very much the same as a tilde in rule. The only difference is that the conclusion doesn't have a tilde as the main operator. The conclusion is simply something that you can't prove given the premises that you have. So you make the opposite assumption of the conclusion. You look to prove a contradiction, or you look to derive a contradiction, and then you can tilde out on your PA that you made earlier in the proof. So let's do a couple of practice problems, and it should be able to make some good sense from it. This first problem is relatively easy when it comes to the tilde out rule. So, same thing as we always do. We always start with the premises that we have and list them. Next thing we're going to do is we're going to look at our conclusion, same thing as always, and we see it's just a letter. It's just the letter P. And in most of these instances, what are we going to do? We're going to try to prove it from our premises. So what do we got? Well, we've got a conditional statement in line 1. We've got a tilde s in line 2. There's nothing we can do with either of those statements. And when there's nothing, or when it happens to be the case that there's nothing that you could possibly do, what you do is you tilde the conclusion as a PA, and you look to derive a contradiction. So here we just tilted the P. Well, now we've got the antecedent to our conditional statement in line 1, so we can get S from 1 and 3, arrow out, 1 and 3. Then we can put S and not S together, doing 2 and 4, ampersand N. There's our contradiction. Now we've got a contradiction. It depends upon our PA, so we can tilde out on the PA from 3, contradictions in 5, tilde out. And then to be 1, 2, 3. Same thing as with tilde in, we remove the PA after we do the tilde out rule. Now, if I were to change this proof to, let's see, if I change this to tilde P instead, and then we have to ignore this tilde here, so ignore those. Then it would be the same exact proof with the exception that it would be tilde in instead of tilde out. So it's the same exact proof, or at least it's the same exact proof structure, just what's your starting point. For us, the starting point is the P by itself, so we would do it this way, and then work to get just the P by itself, doing tilde in, or tilde out, I should say. So same thing as tilde in, just different starting point. So let's move on to the second problem. Now this is a similar case as the first problem. What we're looking at is we've got two premises, and our conclusion is just a single letter. So since our conclusion is a single letter, we might look at our proof and say, well, can I just derive Q? Well, the only problem is I don't see Q anywhere in the proof by itself. I see tilde Q in both places. So, and there's nothing I can do with 1 or 2. So the next step would be to add a tilde to our conclusion, make it a PA, and then look to derive a contradiction. So here we can toss this into our conditional statement in line 2, so that's 2 and 3, arrow out, 2 and 3. Then we're looking at our first conditional, and its antecedent is a wedge. Do we have one of the wedges? Well, yes, we do. We got the tilde in front of the Q, so we can wedge in the P, doing 3, wedge in, 3 is just 3. Now we've got the antecedent there. We can toss it into 1 to get S, so that's going to be 1 and 5, arrow out. 1 and 5 is 1 and 3. Then we can build our contradiction, doing S and not S, from 4 and 6, ampersand in. And then we want to look at our PA. Our PA was tilde Q. We've got a contradiction. The contradiction depends upon that PA. So we can tilde out to do 3 and 7, tilde out. 1, 2, and 3. 3 will drop out once we do the tilde out rule. So that is problem 2. Similar case here in 3. We've got 2 premises, and we've got just a single letter as our conclusion. So we can see if we can derive it from what we've got in our premises. Well, we can't. There's nothing we can do with our premises. We've got conditional in both of them. So let's assume the opposite of our conclusion as a PA, and then try to derive a contradiction. So we'll toss this tilde P into the first conditional statement. Then we can break up this conjunction into Q and S. So that's going to be 4 and out for both of them. Now we can toss the Q into our second conditional, or the conditional in our second line, to get tilde S. So that's 2 and 5, arrow out. 2 and 5, or 1, 2, and 3. We can put both of those together to do 6 and 7, ampersand in. There's our contradiction. It depends upon our PA, so we can just tilde out on our PA and 3. Do 1, 2, and 3, but the 3 drops out, and we're just left with 1 and 2. Now looking here at 4, it's a similar instance as the previous problems. We've got 2 premises, and we've got a single letter as our conclusion. Doesn't look like we're going to be able to get it from anything, so let's do a tilde in, or sorry, PA for tilde out at the end. And let's see what we can get from this. So we can toss the tilde P into our line 1 to get S and T. That's going to be 1 and 3, arrow out, 1 and 3, 1 and 3. We can separate these two out from 4, ampersand out. Now, what else can we do? Well, we still haven't gotten our second conditional out, so we should try to build for it. And we can. We've got the S in 5, so we can do P or S. From 5, wedge in. Then we can toss this P or S into that conditional statement to get tilde T. So that's going to be 2 and 7. Arrow out. 2 and 7s, 1, 2, and 3. Now we've got a contradiction, t and not t, from 6 and 8, ampersand n, 1, 2, and 3. Now we need to tilde out on our PA, which is in 3, 9, tilde out, 2, and 3. 3 drops out. That's that. This problem's a little bit more involved. As you can see, there's a lot of lines here. So here we're going to do both tilde in and tilde out. So let's first list our premises that we've got. And let's look at our conclusion. Our conclusion is an ampersand. So that's telling me I need to prove this and I need to prove this. So can I get Q anywhere from what I've got? No. So what we're going to have to do is we're going to have to do a tilde out on this by doing a PA. And then we can build up our two antecedents from this. So we can do P wedge tilde Q, and we can do tilde Q wedge P. So we're going to do both of those at the same time because it's the same rule for both. And then we're going to toss those into our our conditional statements. So we can get T from 1 and 4, arrow out. And we can get tilde T from 2 and 5, arrow out. And then we can build our contradiction from 6 and 7, and in. It's 1, 2, and 3. Now we got a contradiction. We can, and we got a PA that it depends upon, so we can tilde out on 3. And that's going to be 1, 2, and 3, but the 3 will drop out, so it'll just be 2. So that's one part. Now we got this one done. Now we gotta prove tilde P, and any time in which we're trying to prove a tilde, we assume it's opposite. It's a PA. And then look to derive a contradiction, just like with tilde out, and then work from there. So we can do the same thing as before. We can build both of our antecedents using the P that we've got here. So we'll wedge in tilde Q on both sides. So that's going to be 10 wedge in, 10 wedge in. Then we can toss both of those into our conditional statements in 1 and 2, so we can get T from, looks like, 1 and 11, arrow out, to be 1 and 10, and then we get tilde T from 2 and 12, arrow out, then it's going to be 2 and 10. Then we can build our contradiction, 13 and 14, ampersand n. There's our contradiction. It depends upon our PA, so we can tilde in on our PA, which is at 10. And 15 is our contradiction. That's 1, 2, 10. And then the 10 drops out because we're doing arrow in, or we're doing tilde in. And then we've got this part of our conclusion, so we just got to put them both together. So that's going to be Q and not P from 9 and 16, ampersand n. That's just going to be 1 and 2. So very involved there, but it's just a step-by-step type deal. We look to prove Q, and we are building towards tilde out, and then we are looking to get to tilde P by doing tilde n. This problem is a little bit different. We're going to start mixing in between tilde in and tilde out because they are so similar. It's just good practice. So same starting point as before. Now start with our assumptions. Then let's look at the conclusion. Main operator in the conclusion is this tilde. So whenever tilde is the main operator, we're going to assume the opposite and look to prove a contradiction, or look to derive a contradiction, and then we can tilde in on the PA. So mark this as PA. 3. Let's break apart the conjunction in 1, so that's going to be 1 and out, 1 and out, 1 and 1. Now we can toss that into, or we can toss each of those into our conditional statements. We can do 3 and 4, arrow out, and we can do, let's see, 2 and 5, arrow out to get D. 3 and 4, yep. And then 2 and 5 have 2 and 1. Then we can build our contradiction, doing 6 and 7, ampersand in. And then we've got our contradiction, depends upon a PA, so we can tilde in on our PA, like so. And then we just gotta drop out the PA on the premises. Moving on to 7, we have, it looks like 3 premises. And our conclusion is just a single letter. But it doesn't look like we're going to be able to get it out from what we've got, so we might as well look for a contradiction after assuming the opposite of the conclusion. Well, what can we do? Well, we can toss the P into that first conditional to get tilde, Q, or S. So that's going to be 1 and 3, arrow out, and 3. We can toss the tilde T into the conditional and 2 to get Q. So that's going to be 2 and 5, arrow out, or sorry, 2 and 4, arrow out. That's going to be 2 and 4, 2 and 4. Then here's the tricky part, because we need to make a contradiction. Here could be one side of a contradiction. We could build the other side, since we've got Q. We could Q or S from 6, wedge in. And then we can put them together. So that would be Q or S, and not Q or S, from 5 and 7, ampersand in. Then that's going to be 1, 2, 3, and 4. Now we got a contradiction, depends upon our PA in line 3. So we can tilde, or sorry, PA in line 4. So we can tilde out on that. So that's 4 is where our PA is. 8 is our contradiction. We're tildeing out. So that's going to be 1, 2, 3, 4. 4 drops out. So it's just 1, 2, and 3. On this slide, we got another long one. So we got 3 premises. And let's look at our conclusion. The main operator on conclusion is this ampersand. So we got to prove this and we got to prove this. So let's do it one at a time. It doesn't look like we're going to be able to prove the P because the only thing we got in here is tilde P. So let's assume the opposite of P. Be tilde P as a PA. Look to build a contradiction, and then we'll tilde out on this P. So Let's see what we got. We can toss this into the conditional statement in line 2 to get S and T. So that's going to be 2 and 4, arrow out, 2 and 4. We can also build the conditional or the antecedent for the conditional in line 1, so we can tilde P or Q. That's going to be from 4 wedge in. And so we can do 4 there. Looks like we could have also wedged it on number 3, so that 4 could be a 3 too. It doesn't really matter here. So with this, we can do our conditional out to get tilde T. So that's going to be 1 and 6. Arrow out. 1 and 6 have 1 and 4. Now, we still need to build our contradiction, so let's get the T out from 5. And we can put those two together, doing 7, 8, and in. That's going to be 1, 2, 4. Now we can tilde out on our P, so that's going to be 4 and 9, tilde out on to 4, 4 drops out, because we're doing tilde out. Now we need to try to prove our other half of our conjunction, so we'll assume the opposite of that, Q arrow T as a PA. And we'll look to prove another contradiction. Well, we can toss 3 into here to get T. So that's going to be, looks like 3 and 11, arrow out, 3, 11. Now we can wedge in our tilde P on that Q and 3 wedge in. This time it has to be that Q there because we can't use the PA 4 in this part of the proof. So make sure if it's 3 wedge in, we have to use the Q there. So that's going to be 3. Then, let's see, we can toss this and get tilde T from 1 and 13, arrow out. 3. We can build our contradiction from 12, 14, and in. 1, 3, and 11. Now we can tilde in on our Q arrow T. 11, 15, or not arrow in, we can tilde in. It's 1, 3, 11, 11 drops out because we're tilding in, and then we just need one more line to put them together. P and tilde Q arrow T. That's going to be from 10, 16, ampersand n. 10's got 1 and 2. 16's got 1 and 3. So that's problem 8. Now we got another sort of long one. Again, though, our conclusion is an ampersand, so we just need to prove both sides of it, and then we can get into our or can get our conjunction from it. So what we're going to do is try to prove the first side, which the main operator there is a tilde, so we're going to do a tilde out, or we're going to do a tilde in. So we're going to assume it's opposite and try to prove a contradiction. We can separate both of these if we want. I think we're gonna need to. Let's see. 3 and out. And out. Then we still need to get the conditionals out, so let's just wedge in the pieces that we need to here. Whoops, that is not right. Tilde P, T, 4 wedge in, and then we can Q or tilde P. So that's going to be 5 wedge in. Both of those will come from 3. Toss them in the conditionals, so from 1 and 6, we can get S. And from 2 and 7, we can get tilde S. 2, 7, 2, and 3. Now we just need to put those together. There's our contradiction, so that's going to be 8 and 9, ampersand N, 2 and 3. And what's our PA? Our PA was T and Q. 3, 10, tilde N. 3 will drop out. Now we need to prove P, and we can prove P by assuming its opposite and looking to prove a contradiction. And so we're going to have to do the same thing over again. Wedge in, 12, toss them both in. Looks like we're going to need quite a few more lines. So this one's going to be from, let's see, tilde up here. It's going to be 1 and 13, arrow out. 1 and 12, and then 2 and 14, arrow out. 2, 12, yeah, put them both together. 15 and 16, and in. 15 and 16, 1, 2, and 12. Yeah, tilde out on our PA. 12, got a contradiction in 17. So tilde out. 1, 2, 12 will drop out. And then just have to put them together. Might run out of room here. I hope I can get them both in there. And that's going to be from 12, or nope, not 12, 11. 11, 18, and in. 1 and 2. So this one's rather long, but just so you can see what we did was we proved the first half going through there, we proved the second half going through here. So if I were to give you, actually let's do it the other way. If I were to just give you this part, then you would have just stopped right up to here. If I would have given you just this part here, you would have done this down through here. But since you had to do both of them, you have to prove one, then prove the other. So that's what we did. So it's why it's extra long, but it's not any more extra complicated. It's just doing one part of the proof and then another part of the proof. This last proof is a little bit tricky, but it's pretty, I hate to say fun, but I do find it fun to do because it does take some critical thinking here. So we've got 2 premises. What's our conclusion? Our main operating conclusion is an arrow. So if you remember, with an arrow, we have to assume it's antecedent and look to prove the consequent. So we'll mark that as a PA, and we'll look to prove Q. Well, based on what we have, we can't prove Q because there's no way to derive Q given the three premises that we have. So on line 4, we have to make another PA for tilde Q because ultimately we need to prove Q. Can't do it with what we've got, so we have got to assume its opposite and look for a contradiction. So we're going to do this in a weird order. But first thing we got to do is tilde out on our Q. Well, based on what we've got, we can toss the P into 1 and 2. So if we toss the P into 1, we get tilde Q, arrow S. So that's going to be 1 and 3, arrow out, 1 and 3. Then we can toss the same P into line 2 to get tilde S. So that's going to be 2 and 3, arrow out, 2 and 3. Now we can toss our tilde Q into our conditional statement 4 to get S. So that's going to be 4 and 5, arrow out, 1, 3, 4. Now we can build our contradiction with 6 and 7. Ampersand in. 1, 2, 3, 4. So now we've got a contradiction, and it's important which PA we're operating with here. We're not doing the arrow in just yet. We're still looking to get a contradiction and tilde out on that Q. So that's what we're going to do. We've got a contradiction. It depends upon the PA that's associated with our design to do tilde out. So we are going to tilde out on our PA in 4. So that's going to be 1, 2, 3, and 4. The PA in 4 is getting tilde outed, if that's a verb. I guess we can say it's a verb in logic, but we're using our tilde out rule on our PA in 4. So we drop the fourth premise, and then now we've got our Q that we are looking to arrive at by assuming P. It depends upon the PA made of P. So we can arrow in from 3 and 9, arrow in. That's going to be from 1, 2, and 3. 3 drops out because we're doing arrow in. And then the rest of these numbers are not needed. Don't know why I put them on there, but this one's pretty complicated because it requires some thinking about what the conclusion is and what you need to do. So we made the first assessment, which was this is a conditional statement, so we needed to assume this and prove this. Well, it's like this is our new conclusion. So if our conclusion was just the letter Q, and we can't derive it from the premises that we have, then we need to assume its opposite, try to build a contradiction, and tilde in on it, which that's what we did. So it's like an opening and closing of the proof. The PAs are contaminated sort of with each other. We've got 3 and 4 together through at least up to line 9 once we tilde out on PA4. But again, just take some thinking about processes here. Where main operator is an arrow, so we're going to try to do arrow in on the conclusion. We assume the left side look to prove the right side. The right side is a single letter, and we can't prove it given what we have, so we need to assume its opposite, look for a contradiction, and then that's what we did, and then we could arrow in once we have arrived to the consequent. So that's the first set of practice problems for tilde out rule.